Okay, good day, everyone. Do you have any question from homework? Anything we want me to go over before we complete the project number two? Okay, so I guess yeah, you can talk to me later, right? And also, a quick announcement: I have a meeting to attend after this class around 12 p.m. So I will finish the class well earlier today, right? So after I demonstrate the problem from the project number two, I will finish the class. Okay. All right. First of all, let me just share the screen with you. Here you go. Okay, so you can open the PowerPoint from last class. Okay, so let's open the PowerPoint, and I'm gonna go over that. So open the section 1.4, 1.5 PPT, and I'm gonna use the last example right from that as an example to show you how to construct the straight line, how to graph the straight line, and then come up with all those things in Excel. So you can go to the last part of the PowerPoint. Here you go. Okay, so this will be the example. So we're gonna use this example to come up with the cost, revenue, profit functions in Excel. And after that, graph each one of that, and also find a break-even point for this question. Okay, so now open the Excel program. Also, quick thing, something really quick is your last question in the last project is about the okay, not this. It's about break-even point, right? So revenue cost function, and also try to find out the break-even point. Okay, so you can open that project number two. And you'll be able to tell, they are very similar in nature. So once I show you how to do one of this, you should be able to finish this on your own. Okay. So here's this one, right? So very similar, producing this 17,500 units for this amount of money, 22,500 units for $912,500. Each unit could be sold for $20. So you want to use Excel to find the cost, revenue, profit functions, and graph them. Graph each one of that, and then also show the cost of producing 30,000 units, and then also find what is a break-even point. Okay, so we're gonna do similar things for this one, right? Okay, so we got given two conditions: 7,500 units, cost is 650,000. 10,000 units, cost is 850,000. So let me open the Excel program. Yes, I can just copy this and put it into the Excel. Okay. Copy. All right, so let me share the screen with you right now. Here you go. Close this. Okay, paste it. All right, so this is the question we're looking at. Right. I need to do a little merge center. Yeah. That text. Okay. You can also open a PowerPoint on the side, and then so we can just look into this. So now first thing we do the data entry, right? So we just list those two cells. Okay. And just resize a little bit. Okay, so first thing is come up with the cost, revenue, and the profit functions. So we work with the cost function first. So cost function, given two order pairs. So first order pair will be 7,500 units, and then the cost is 650,000. Okay, and the second order pair, it's 10,000 units, cost $850,000. Based on these two, we can find a slope at, right? Find a slope for this. So we do equal sign using 850,000 minus 650,000 and dividing by 10,000 minus 7,500. Okay, and then you get a slope first. Okay, I don't think they don't want a comma embedded into the number, so yeah. So the slope is 80, right? And then we also need to find the y-intercept b. So we are using the point slope formula. So y minus y1. So here the y minus y1. So find the y-intercept b first. Y equal mx plus b. So y value here is we're using either one of these order pair will be good. So that will be 650. Okay, so we're using 650,000. That's y minus mx, right? So m is 80. You can use the cell number 80 times 7,500, and that we get the y-intercept b. Okay, 50,000. So now we have the cost function. So cost function should be written as y equal to, or c of x, right? Represent a cost function equal to 80 times x plus 50,000. Okay, so we take out the cost function, and the revenue function r of x, and just equal to each unit is sold by $100, so 100 times x. Okay, and the profit function p of x is equal to revenue function r of x minus c of x. Okay. Yeah, so now once we have all of this, it should be capital letter C. All right, so the profit function look like this. Okay, so it's 100x minus 80x and plus 50,000. Also, for your homework, in order to, make it more accessible, you should either complete your homework in Excel, right? So just work out all the homework problems in Excel or using the Word. In that case, it's very easy to convert it to PDF file after that. So I strongly recommend you guys to do a homework in Word, Microsoft Word or Microsoft Excel. Okay, either one. And Okay, so now once we get this, expand it, so we get 20x minus 50,000. Okay, that should be profit function. Now, second step is to graph this, right? So once we have each one of these, we want to graph it. Okay, so we start with the cost function, okay. 80x and then plus 50,000. So if you want to, okay, just like what I showed you last time, right? We're gonna use this format and get some order pairs. Maybe let's use 5 order pairs. Okay, right here, center this bold, all borders. Okay, so now we can pick some value, but make sure you pick some value which is close to the actual reality, right? You see here, you know, production level is on a 7,500, right? All the way to 10,000. So I guess I will start with the 70,000. Don't pick some number which is way off, right? We should pick a number which is close to this, close to actual production level, right? No, 77,000 and 8,000. Same thing for your scenario, for your probably do the same thing. Okay. So once you have a couple of them, you do that, drag it, right? So all the way up to 11,000. The actual production in this case is 10,000 on the high side. So so this is good. And now again, the slope here, we're going to define the slope. Slope is 80, and then y-intercept b, that's 50,000. Okay, so we have both. So now we're just going to calculate that using slope. So one more time, I'm going to lock the cell. We call this absolute reference. Okay. Here, and then multiply this by actual unit produced and sold, and then plus the y-intercept 50,000. So this should be put $sign in front of it, put $sign in front of it. Okay, so by doing this, the good thing is we only need to calculate it once. So the cost of producing 7,000 units, 610,000. Now you can use Excel to calculate the remaining numbers. And once you have this, then we can sketch the graph. Okay, so highlight the entire table and go to insert. And then you're going to click on the second option, right, with a line on it, right? So you get that, you know. So we come up with this graph. Let me just resize it a little bit. It's a little bit too big. You can resize it to the proper amount. Okay, then we can put it on the side, right? So we take care of the cost function by showing a graph. And also we can keep doing the revenue function. Okay, so similarly, since we picking this as a x value has a cost for cost function, we should pick the same x value for the revenue function in order to be consistent, right? All right. So now let's look at it. So same thing, we need to copy this. Okay. For the revenue function. Now we're going to paste it here. And we're going to find out what is revenue for each one of this. Okay, so revenue, the slope is 100. So we're going to define the slope 100. And y-intercept is 0. So we can just put it there. Okay. And now we're going to do slope. Again, we're going to do the absolute reference for the slope. And multiply by the quantity produced. Okay. And add in the y-intercept 0. Okay. So if you want to skip this 0, that's okay, right? In this case, you can just do that without, you know, adding the y-intercept because it's 0. Okay. That would be more convenient. So now we have that, and then just drag it all the way to the bottom. We get all of that. Now you just graph it, right? Similarly, go to insert and then go to scatter plot, pick the second option, so get a graph. So once we using the same number, so the graph will look very, very similar, right? The revenue function. So just put it on the side. And then the third one is create a profit function. Okay. So the slope is 20,000, y-intercept is negative 50,000. So we still pick the same x values for the profit function. Okay, paste it. We also need to p of x. Okay. Highlight the table, format it a little bit, center that, all the borders. So now define the slope. Slope is 20, and then y-intercept is negative 50,000, right? Make sure you put in the right number, not 50,000, negative 50,000. So the y-intercept including the sine. Okay. So now once we have that, we can just calculate the profit for each production level. So using slope. Okay. Similarly, we're gonna put a dollar sign, put an absolute reference, dollar sign around a bit, and multiply by 7,000 unit produced, and then add in the y-intercept, right? Okay. So plus minus still minus, so there's no conflict, right? Even though we add in the y-intercept, since it's negative number, so plus minus is minus. So still subtracting 50,000 here. Dollar sign in front of it, dollar sign here. So once we calculate one of this, now you can just drag it to the rest of it. Okay, so this is a profit based on different production level. Now, similarly, you just go to insert and go to scatter plot, second option with a line. Okay. And then we get the profit function, right, in a the graph. Okay. I also want to show you something really, really nice. So we actually could put all this graph together on the same graph. So you just copy the cost function, copy this. Okay. Something extra. I'll show you. Okay. Paste it here. And also copy all the revenues, right? Copy that. Paste it next to it. Okay. Change. Okay, I guess I couldn't do that. You should always stick to the same number. Okay, so maybe we calculate the revenue function here. So do that. R of x. And P of x, put it all together. So we start with the revenue. So it's 100. Okay, so you can just do cell, right? Let's go back to the cell and then use the absolute reference. And multiply that by the slope by the production level, then we'll get that. Okay, all the revenues, can I get the rest of them? Profit function is equal to revenue minus cost, right? Okay, using revenue minus cost, get a profit. Now we have that. Okay. Let's double check, it should be the same number, right? It should be the same revenue, should be the same profit. Now let's just sketch the graph here, and then let's see. Okay. So, sure. Yeah. Go ahead.
You know how you just put in for P, like
Profit function.
cost or
Mhm.
minus revenue? How come you didn't need to use the dollar signs?
Oh, here because you see revenue and then cost changes for each scenario.
Oh, I
So we keep
see.
it float, right? So keep it as a variable. Very
That's
good question, though. Yeah, that's why I just using the overall principle, profit equal to revenue minus cost instead
okay.
of
Thank you.
using. Right. Does that make sense?
Yeah.
Okay, very good. So now I'm going to show you something which is nice. So you highlight all of this, you'll be able to present it, all these three functions on the same graph, right? So go here, you see, and then put on scatter plot. Yep. And then you'll be able to put a profit. This is cost. Cost is the, yes, cost is right here. This is the profit revenue function. So revenue function is always on top of the cost function. That is good thing, right? So meaning at each production level, revenue is always more than the cost, meaning the company is making a profit. And then this is the profit function, right? And as you can see, the slope for the revenue function actually is steeper compared to the cost function, compared to the profit function. It also tells us a lot, right? Once you put all three together, uh, graph of cost, revenue, and profit function. Yep. Okay. As you can see, if you want to see the break-even point, right, somewhere down here, we can come up that. The only thing is you just have to insert. As you can see, break-even probably occurs somewhere down here, so we need to plug more numbers. Okay, so go back here a little bit. Go back to our. Let me just move it a little bit inside. And here we guess we just need to insert a couple more numbers. So here we're gonna insert, we want to show the break-even point from the graph. We just need a couple more. Okay, so that means we're gonna start with okay, we can just drag this backwards. Let's see if we can, no, we can't drag it backwards. So that means we could do this, 4,000, 5,000, and then let's drag. Yep, so similarly here, let's see, we can drag backwards. I guess we could do that, yes. We can drag it backwards to get all these calculations. Okay, now if you sketch it one more time, right? So let's delete this. Then you'll be able to see a break-even point presented in the graph. Just graph. Okay, now let's graph it. And we know that break-even point occurs at, we can easily find out that 20x plus 50,000, right? So break-even occurs at 2,500. That means we still know, we still hasn't get done to that yet. So no, this is still, we still need a couple more. Okay. So let me just insert a couple more. So 2,500. So we start with 2,000, 3,000. Okay, 2,500 is between those two. So we just get that. Get that. Okay. Yeah, so as you can see, break-even occurs somewhere here. See, between negative 10,000 and 10,000. Now let's sketch the graph of this. So maybe calculate the break-even point. It's better to guide us draw the graph. So your graph will look a lot better, right? Okay. And then also show the break-even point from the from the graph itself. We pick this, here you go. So you see break even occurs somewhere here. This is, yeah, 2,500, right? So this is where the orange, dot meet with so somewhere here. So 2,500 here. This is 3,000, 2,500. They becomes invisible here, right? So 2,500 is the break-even point, and then you can easily see from the graph. Okay, so that we have this. So any question on the graph? So I guess as a summary graph, this is nice. It give you all three graphs together, so you have better idea how this thing works out. So this is sketching graph part, and then second question, I think they ask us to find out the amount of the revenue cost at 60,000 unit produced, right? So do you want to find out that? And this one, you just have to cost of 60,000 units. So you just have to plug into the function, right? Replace X here from the cost function with 60,000. So let's go back. So we're gonna do 80 times 60,000, adding 50,000. Okay, that would be the total cost. Yes, and then revenue of producing I guess we can do producing 60,000 units. So just resize it a little bit. Okay, we'll get that. Now we have revenue producing 60,000 units. So similarly, we're going to plug into the revenue function. So it'll be 100 multiplied by 60,000. So revenue is this amount. So the profit of producing 60,000 units. You could just use a revenue minus cost, right? Revenue that minus cost, and that's the profit. If you want to format this three, we can easily format it with the dollar sign in front of it. Okay, so we can do that. No decimal, just yes. Okay. So we get this, right? Cost, revenue, and then profit. And the last thing is for us to find out the break-even point. So break-even point. We just basically look at the profit function and make sure there's no profit, right? Equal to 0. So we solve for X. So basically just using 50,000 divided by 20 to get that, meaning P of X equal to 0. Okay. And we're just using 50,000 divided by 20, right? So that's units. Meaning if you produce 2,500 units, that's break even. And you can also easily find it from the graph, right? Once you put all three together, you see break even occurs somewhere here in the middle of 2,000 and 3,000. This is 4,000. This is 3,000 in the middle. And then between 2,000 and 3,000, 2,500, you have a break even point. Okay. All right, so that should be sufficient for you to complete the, so if you want to, yes, that should be sufficient for you to complete the last part of the project number 2. And there's no new project, right? The next project is on the is actually based on the chapter 2, so we can only get started next Friday. So today, if you finish project number 2, yeah, feel free to leave. Also, I have to log off at 12 p.m. I have a meeting to attend. Okay, so yes. Any questions before you get started? I can post the solution of this right now. Let me save it first, and then I'll post it in a second. Any question before you complete the project number 2? Okay. All right, in that case, I will put you in the breakout room. So we still have like about 15, 20 minutes. So if you have any question you want to ask me, feel free, right, to raise your hand. I will join your breakout room.